Hello everyone. So in this video again we have got a very interesting question pertaining to integers and selection of integers. So basically factors. So let's take a look at the question. Find the number of ordered pairs of positive integer m comma n such that m square n equal to 2 to the power 20. So the equation that we are given here is m square n equal to 20 to the power 20. My bad. So now what we need to do is basically we need to factorize 2 to the power 20. So how are we going to go about this? So basically we know if we take 20, 20 can be basically written as 2 to the power 2 and 5 to the power 1. So if we write as 21, we can see that the power is double here and the power remains the same in terms of 5. So therefore we can actually conclude 20 to the power n is basically 2 to the power twice n into 5 to the power n. So therefore prime factors of 20 to the power 20 is 2 to the power 40 and 5 to the power 20. Okay. Now we are given m square n equal to 20 to the power 20. So what does this mean? So this basically means that we want to select square, or sorry, my bad, perfect square factors of 20 to the power 20. So how many perfect square factors of 20 to the power 20 basically exist? Let's take a look. 20 to the power 20, this can be written as 2 to the power 40 into 5 to the power 20. So if I am to write this as a factors of perfect square, so let's take 2 square 20 into 5 square 10. Okay, here this and this, both these terms are perfect squares. Okay, so now number of perfect squares will be 20 plus 1 into 10 plus 1, which gives us 21 into 11, 231, which is our required answer. So this is the number of ordered pairs. So this is one way to actually go about this particular problem. So this problem can also be solved in a very different manner itself. So let me show you how it can be done. So here again in the method number 2, what we do is that, so here 20 to the power 20, let me write this down as 2040 and 520. Okay, so here if m square n equal to 20 to the power 20, so there must be non-negative integer a comma b comma c and d such that m equal to 2 to the power a and 5 to the power b and n equal to 2 to the power c and 5 to the power d. Okay, so here we can again write as far as power of 2 is concerned, so twice a, because m is squared here, twice a plus c equal to 40 and twice b, again twice b because m squared we have, plus d equal to 20. Okay, so having said that, the first equation a's value will be from 0 to 20. Okay, so for every particular value of a, we have a value of c as well. From c will be from 0, a equal to 0, c will be 40, a equal to 1, c will be 37, so something on that. So a's value will range from 0 to 20, and subsequently for every value of a, we'll also have subsequent value of c as well. So with that said, there are total 21 solutions. And second equation, value of b will be from 0 to 10. So in total there are 11 solutions. Okay, so now total solutions will be 21 into 11 equal to 231, which is a required answer. So hopefully these things are clear to you, how we have actually come across, how we actually tackle the problem and both the methods that we have adopted towards solving this particular question in general. You can use either one of them. I have just shown you both these methods so that you can develop a better understanding of the same as well. So with that said, I am signing off. Thank you so much.